Right. It's Monday, April 7th, and this is the worksheet we're looking at, but I'm going to start by titling my notes. It is Algebra 2, and we are still in Unit 1. Unit 1 is a very long unit for us because there is lots to learn. The factoring was the first part of that unit, and now we get into the good stuff. So, let's see. Today is day 9 of class, which means you all are a third of the way through Algebra 2. Exciting. It goes by quick. So this is day 9. Notes. And again, it's Monday, April 7th. Okay, so we have been talking about quadratic expressions. We've been factoring, and we even just slightly last week introduced the quadratic formula. Fun stuff. So today we are going to be talking a little bit more about quadratics, but this time equations instead of expressions. So I'm going to title this Solving Quadratic Equations. And again, there's two ways to solve these. We can solve by factoring, or we can use that quadratic formula. And I will pause real quick. All right, so when we are solving a quadratic equation, we want our quadratic equation to be in this form. ax squared plus bx plus c, just like we're used to. And this time it's equal to 0. And you'll notice on this worksheet that most of the problems are set up this way. Numbers 1 and 2 have that format. Number 3, what's missing here? A B. We don't have a middle term. So we'll talk about what we do in that case. Looks like number 3 and number 4 are like that. Let's see. And then we start moving on to problems like number 11, where now I have x squared and then my equal sign. It's not equal to 0 anymore. Now it's x squared equals 11x minus 28. Oh my goodness, what would we do there? We're going to talk about that today. So let's talk about how to get to this form that we call standard form. So I'm going to title, or not title, I'm going to label that. This is our standard form. There we go. So I would like for us to look at number 11 specifically to start. And I am going to just rewrite that problem a little bit bigger so we can all see it. Good morning. Number 11 says x squared equals 11x minus 28. So if we wanted to either factor this or if we wanted to use the quadratic formula, we couldn't do that yet because it is not in standard form. I have my ax squared here, but my b term and my c term are not on the same side of the equal sign. Does anybody have an idea of what we could do to change this equation to get it to standard form? Any ideas at all? Yes, yes. So equations are Amazing, because we can rearrange them by using our inverse operations. That's a word you might not have heard in a while. Does anybody know what inverse operations are? I'm going to get a sticky note out because this will be a mini note we take. Inverse operations. How about just the word inverse? What does inverse mean? Or are we not sure? Inverse. I know it's Monday morning. Anybody have a guess what inverse might mean?
The opposite.
The opposite. Yes, that is the exact definition. Inverse means opposite, meaning, for example, an operation we might work with would be addition. Operations are the things we do to numbers, such as adding, subtracting, multiplying, and dividing. So, if the first operation I'm looking at is plus, addition, what would the opposite or the inverse of that be? Subtraction, minus. Good. So, if I see a number like minus 28, if I wanted to move that to the other side of my equation, we would use inverse operations to do that. Because we want to get rid of 28 on this side of the problem, we need to get it to cancel out. Meaning, whenever I either add a number to this or subtract from it, I want it to end up being equal to 0. So, if I have minus 28, what is the inverse operation I would use to get rid of it? Plus. So, we're going to do plus 28 on this side of the equation. And when I say side of the equation, I'm talking about that equal sign. That equal sign separates the two sides. Whatever I do on one side of an equation, I must do it to the other side as well. So where else would I add 28? 11. So under 11 would still be on the same side of our problem. This line is separating the two sides. I already did it on the right side. I need to do it on the left side too, right? So what is on the left side? X to the power of 2, x squared. So I'm actually going to add 28 over here under x squared. Now what happens to minus 28 and plus 28? They cancel out. Okay, so we'll draw a line. And whenever I bring everything down to the next step, x squared and 28, can I combine those? No, I can't. These are not like terms. They don't both have x squared attached. So we're going to bring them both down, but we're going to bring them down separately, meaning we will have x squared plus 28. Then we'll bring down our equal sign. So I brought down my x squared, I brought down plus 28, I brought down my equal sign. What is left to bring down? 11x. Good. Okay, so now I am one step closer to having my equation in the form I want it. I have my ax squared done. I have plus 28, no variable, so would this be b or c? C. So what's left to do? Yes, now I need to bring my 11x over to this side as well. My goal is to get ax squared plus bx plus c equals 0. So if I have positive 11x, how do I move that over? How do I cancel it on this side and bring it to that? We're going to subtract it. Good. So I'm going to do minus 11x on this side. And I need to do it on the other side as well. On the other side of the equal sign, minus 11x. Okay. So at this step, what happens with my 11x minus 11x? It cancels out. Now, we don't want to just cancel it and leave nothing. I'm going to bring down my equal sign. What should I write over here? 0. 11 minus 11, 0. Boom. There we go. Now, how should I write these three terms over here? What order should I put them in?
A, B, C.
A, B, C. So what's my A term? My x squared. So I'll bring that down first. What's my B term? Good. Minus 11x. And my C term is the only thing left, plus 28. And now we have our equation in standard form. We rearranged it. So sometimes if your equation is not already in that form, we will need to do a little bit of rearranging to get it there. And that rearranging is just done the same way you would solve any equation. We're just using inverse operations, the opposite thing. So there's our first one. Now for number 11, once we've gotten to this point, I'm wanting to still solve this problem. I want to solve to see what my values of x are. There's two ways we could solve this. The first way is by factoring. So why don't we try that first? If my quadratic begins with x squared minus 11x plus 28, what would my value be for A? 1. Good. So A is 1. What's my value for B? Negative 11. And what's my C? 28. Good. So now we're back to doing what we've been doing. How do I factor this?
On factors of C.
Yeah, let's look at the factors of C. So if C is 28, and I'm wanting my factors to add up to B, which is negative 11, what signs will my factors have and why? So one negative and one positive. If I multiply a negative times a positive, what kind of answer will I get? A negative. So that would be correct if we had negative 28. I think you're thinking of our B being negative, right? So with a positive C, we have two options. We can either have a positive and a positive or a negative and a negative. So which one do you think it's going to be? The negative and negative. Good. Now why do we know it's going to be the two negatives? Because we're trying to use addition to add up to B. And if our B is negative, two positives will never add up to a negative. We're going to need the negative signs. So let's start thinking about our factors of 28. We have negative 1 and negative 28. Negative 2 and negative 14, and I'm just looking at my factor sheet. Negative 4 and negative 7. Okay. Is everybody following up to this point? Okay. So now I have my factors listed out. What would I do from here?
Add them up here. B.
Yeah, let's add them up and see which pair adds up to B. So negative 1 and negative 28, that gives me negative 29. Negative 2 and negative 14 gives me negative 16. What about negative 4 and negative 7? Negative 11. Perfect. Okay, so since these add up to negative 11, we're going to be using negative 4 and negative 7. And what will our factor pairs look like? How should I write them? Yes, x minus 4 and x minus 7 equals 0. Okay, we're almost done. So we have factored. Where do I go from here? How do I solve?
Bring down x minus 4 equals 0.
Perfect.
7 equals 0.
X minus 4 equals 0. X minus 7 equals 0. And how will I solve x minus 4 equals 0?
Inverse operation.
Inverse operations. Opposite of minus 4, plus 4. We were doing this the whole time. Maybe you just didn't know the name of it. We're using inverse operations to solve. So we're going to get x equals positive 4. Are we done?
No.
One more. Okay, we've got x minus 7 equals 0. Same thing as over here. We'll add 7 to both sides. Those cancel. And we get x equals 7. And to write our answers as one item, we will just say x equals 4, comma 7. And circle the whole thing. And there we go. That's our answer. I hope factoring at this point is starting to feel a little bit easier, a little bit more natural. It usually does. Once you're forced to do it a million times, it tends to stick in your brain a little better. But before we try this using the quadratic formula, do we have any questions?
Yes.
Tell me.
With all of these steps, like, I'm just wondering, is there a way to remember all of them? Because if we're gonna with factoring, there can be a million steps. Like,
Yes.
If there was no factors that would match in the factor pair, then we have to go that whole like mismatch.
Yep, yep.
And then the formula, which obviously we're still learning that one. Like, I'm just confused of how I'm not gonna get lost.
So, are you more concerned about the factoring or the quadratic formula?
Right now, the quadratic formula.
Right now, the quadratic formula.
That's new.
Yes, that is new. And we're going to work on that more today. I think,
I guess it's just because there's so many steps. Like, when I was looking at my quiz, I
Right.
realized, like, I'm doing it right, but I'm forgetting little things that
Right.
make it so I have, like, marked off that's wrong just because of the littlest.
right,
'Cause
right.
I'm doing it for so long that I'm forgetting what I've done.
So I do have a trick. And it's a video that, if any of you know Jeremiah Fuller, one of our students here, he is like a mathematician, very intelligent. I don't know how he knows math so well. It's very impressive. But he showed me a video that, let me post it to your Google Classroom and I'm going to show it to you guys. It's actually a trick for solving quadratics whenever your A is not 1. That saves you a lot of time. So this might be the answer. Let me pause this and I'm going to show it to everybody. If you're watching at home, the video will be posted on Classroom. Okay, so we're back from watching that video. I'm going to rip out this page after I label it as my first page, and we are going to look at that trick for factoring when A is greater than 1. Makes our lives a little bit easier. Okay, so this will be page 2. And day 9, notes continued. Now, of course, if you like guessing and checking a million times, you can do that. Absolutely. But if you want to save some time, I do think this trick is really worth giving a try. And we are going to use an example from this worksheet. I'm going to look at number 8 here. Number 8 is 3x squared plus 14x minus 49. So let's see. 3x squared plus 14x minus 49 equals 0. And we're going to solve by factoring, but using the quote-unquote illegal trick that we just learned. So let me just label this. So normally when we are trying to factor to solve a quadratic equation, when our leading term, that coefficient is bigger than 1, it's 3, and we cannot remove it by dividing everything by 3 because 14 and negative 49 are not divisible by 3, we can try including it in our parentheses where you have 3x and x and then do a bunch of guessing and checking, but that can be time consuming. So here's what we'll do instead. I want to get rid of this 3, so I'm going to multiply my end term, the constant, negative 49, times 3. Just negative 49. And we're going to say that this temporarily cancels things out. So I'm going to bring down x squared without the 3 plus 14x minus, now we just need to figure out what is 49 times 3. Negative 147. All right, I'll believe you. Negative 147 equals 0. Now, in the video, they used like x prime squared plus x prime. I'm going to ignore the prime thing because I think that is going to potentially confuse us a little more. We're just going to rewrite it and keep in mind that since we multiplied by 3 at the beginning, we're going to need to divide by 3 at the end. That's the only extra step. So now we have this quadratic equation where when we factor, since a is 1, we can just do x and x. We won't have to do any rainbow method, any guess and check. We can just see, do the factors of negative 147 add up to b, or 14? So our factor sheets don't go up to 147. So we might have to do a few to make a list here. Now, since our C, our negative 147, since it's negative, what kind of factors will I have? Signs. What signs will they have? A negative and a positive. Good. They need to have different signs so that they multiply to that negative number. So let's see. I'm going to start with the smallest number that we can. I know it's not divisible by 2 because it's odd. So maybe we'll try 3. 147 divided by 3. Okay, that works. 49. So I'll do negative 3 and 49. I don't think it'll be divisible by 4. Let me just make sure because that one was weird. Yep. 147 divided by 4. Nope. 147 divided by, it won't work for 5. Maybe 6? Let's try it. Nope. Let's see. 1 by 7. Let's try 7. That works. Okay, so we've got negative 7 and 21. Now already that's looking close because I'm going to have 21 minus 7. Let's see what that gives us. It works. Negative 7 plus 21 equals 14.
Did not eat that one.
Yes, this just saved us a lot of trouble. So, because it does equal positive 14, what do we do with these numbers? We're going to plug them in. So, we're going to do x minus 7 and x plus 21. And it's still equal to 0. And now I have my factors. What would I do next? Yeah, we're going to bring both of these down and set them equal to 0 so that we can solve. So we've got x minus 7 equals 0 and x plus 21 equals 0. And you will notice that whenever we have just x minus a number equals 0 or x plus a number equals 0, pretty soon you may begin to recognize that your answer for x is just going to be the opposite sign. We would add 7 to both sides, which would give us an answer of x equals positive 7. We would subtract 21 from both sides, giving us an answer of x equals negative 21. But are we done? No, because we used that illegal trick of multiplying by the leading coefficient of 3. Now we need to take these answers and divide by 3. That is the last step. So, x equals, we'll do 7 divided by 3 and negative 21 divided by 3, which would give us, let's see, 7 divided by 3 will give us 2.3 repeating. And negative 21 divided by 3 should give us negative 7, I believe. Yeah, negative 7. And that's our answers. So, the big note to take in this problem, I'm going to kind of back it up and get this down. So, we need to multiply by 3, and at the end, we are dividing by 3. Okay. Does this make sense? You feel a little bit easier than doing the rainbow method?
Yes.
Do we have any questions about this? We'll do a few more just to make sure we have that. Any questions? So I'm just going to write when a is greater than 1, multiply a times c, and then divide your answers by a at the end. And divide by a at the end. Now this is only going to work when we are solving for x, which luckily that's all we're doing from now on. I'm not going to be as worried about us finding factor pairs, more so finding the actual values of x. Okay. Any other questions before we try another one? Okay. Can I move this? Is anyone still writing it? I can leave it if we need. Yes, absolutely. I'm happy to do that. Yeah, if anybody wants copies of anything at the end of class, just let me know. So let's do another one like that. I'm going to make page 3. And if you don't like that method, you don't have to use it. That's the beauty of math, is you can do things in about a million different ways. You can stick with the rainbow method, or let's say you just don't like factoring at all. You don't ever have to factor if you do the quadratic formula, if you prefer that. But let's do one more like that before we try these on our own. Okay, so let's see. Let's do one that has to be rearranged. Let's do number 15 on our worksheet. That's x squared plus 17x plus 49 equals 3x. So number 15. X squared plus 17x plus 49 equals 3x. Okay. Now, right off the bat, what do we notice about this problem? Yeah, we've got 3x on the other side of our equal sign. We want our equation to be equal to 0 so that it's in standard form. So what would I need to do to get this in standard form? Inverse operations. We need to do the opposite to get this equation rearranged. Now I have a positive 3x over here. Everything else is in order. What step would I need to take here? Yes, we're going to subtract 3x from both sides. So I've got minus 3x here. Now, are there any like terms that I can subtract from over here? Yeah, the 17x. So we're going to subtract 3x from there as well. Okay. And what happens next?
You're going to bring everything down.
Bring everything down. X squared plus 17x minus 3x. What's that going to leave me with? 14x. Good. Plus 49 equals, my 3x's will cancel out, leaving me with 0. Okay. So this is one that we actually won't have to use that fancy method. I didn't even think about that. Since we have a of 1, that's okay. We can do it anyway. Okay, so if I wanted to solve this equation, what could I do next?
Factor.
We could factor, okay? What are my factor pairs going to look like? What will be the first term of each pair? X. Okay. And repeating the process, we'll find the factors of C. And what do they need to add up to? 14. Good. Now, do you think we'll have 2 positives or 2 negatives? 2 positives. Good. Okay, let's see. Factors of 49. We have only two options. 1 and 49. 7 and 7. Which one is it? 7 and 7. Because 7 plus 7 is 14. So, plus 7 plus 7. What's my answer?
X equals negative 7.
X equals -7, and I'll show the work for that. You only have one answer this time because our factors are the same. So we have x plus 7 equals 0, minus 7, minus 7, x equals -7. Perfect. Okay, so that was more practice rearranging. That wasn't as much practice with the that new method we learned. Let me give you one that we do use that method. Let's look at number 17. Now we have, and I'm going to write x instead of k, if that's okay with you guys. I just prefer using x. So 2x squared minus 14 equals -3x. Okay. What should I do first?
Add 3 to both sides.
Yes, let's add 3x to both sides so that we can get our equation in standard form. Those will cancel. Now when I bring everything down, what order do I need to write these in? A, B, C. What's my A?
2x squared.
Good. 2x squared. My B? Good. Plus 3x. And my C, only thing that's left, minus 14 equals 0. Here we go. So if we wanted to, we could put 2x and x and do our guess and check method, but let's try that new way that we did with this problem, where we multiply the a to the c and divide by a at the end. So what would my next step be here?
We divide by.
We're going to take, yes, our a term, which is our 2, times our c term, -14. So I am multiplying by 2 here. And whenever I do that, even though mathematically it technically wouldn't necessarily cancel out that 2, we're going to pretend like it does because it's a special method that works. So I'm going to rewrite my equation as what? What is my new first term? X squared plus, good, plus 3x. Yes, minus 28. And we got that 28 by doing 2 times -14 equals 0. Now this works. We can multiply by 2 at the beginning, but what is the thing we'll have to do at the end? We will have to divide by 2 at the end. If not, we will not have the correct answer. So now I have an equation where my a is equal to 1. I won't have to do guess and check anymore. So what's my next step?
Factor out 28.
Yeah, let's find the factors of that -28. And what will the signs of our factors be?
Positive
a positive and a negative. They need to have different signs since we have a negative c. And 28, we've got 3 factor pairs. 1 and 28. Yeah, or -1. Good. Let's see. 2 and 14. Or 2 and -14. And then 4 and 7, right? So we could either have +4 and -7, or -4 and +7. And how will we know which of these pairs is the correct pair?
Adding them up.
We're going to add them up, and they need to add up to
Positive.
+3. Perfect. So,
-4 + 7.
yes, -4 plus 7 equals 3. So, that's the numbers we'll use. X minus 4, X plus 7, and let's see. Where do we go from here?
Now we divide.
Say that again.
Now we divide.
Now we can divide as soon as we know for sure what our x values are, right? So if it's x minus 4 and x plus 7, what are my numbers going to be? Yes, we're going to have a +4 and a -7. Is anybody unsure how I went from the factor pairs to the answer without writing that equation?
You just flip the sign.
We just flip the signs. You'll notice in every problem, whenever we have just x and x, whatever number is in there, the opposite is your answer. We had a +7, x is -7. Here we have -4 and +7, +4 and -7. It's just the opposite. But if it makes you feel better, you can always write the equations out. So I have 4 and -7, and just like you said, Seth, since at the beginning we multiplied by 2, now we just need to divide everything by 2. And what is that going to make our x values? 4 divided by 2 is 2. -7 divided by 2? 3.5. What's the sign on it? Negative. And those are our answers. Kind of a cool trick. Definitely makes life easier as long as you remember to divide by whatever your number for A is at the end. If not, you got a totally different problem. But it does help. It does help. Okay. So, Seth, does that make things a little bit easier?
It gives like more like of a checklist.
Yes.
Steps, I guess. What I could come talk to you about is going over writing down steps. Like
Yes.
A checklist. So because I guess my biggest issue is like the math makes sense. Like,
Right.
I can do the steps and they make sense, but like I guess I forget certain little things. Like,
Mm-hmm.
I forgot to write equals 0 on one of my
Right.
problems, and while it was right, just because of that, I got marked off one.
Right.
Because I missed equals 0.
Mm-hmm.
I guess I just need something to look at and make sure I've gotten everything.
So maybe we would benefit from sitting down and just creating like a step-by-step guide to follow. Okay, I'm going to keep that in mind and see what I can come up with. Any questions about what we just did?
That's way easier than
I agree. I agree.
the quiz. Like I ran out so much room. I was going into the next.
Right.
So I had to get another piece.
And this will make it so much easier. So much
I was
easier.
forgetting which ones I was doing. Like I was repeating
Right.
doing the same ones.
And you know, factoring, I will always say factoring is the hardest part to learn if it's new to you in Algebra 2. Once you get past that, it really will feel a little easier. Okay, so I'm gonna tear this out, and I want you guys to try a couple of those on your own. And we'll talk a little more about the quadratic formula after this. Let's see. I want you guys, I'll circle some. Try solving number 6, number 7, and number 18. Try those 3 on your own, and I'm going to write them out larger. So number 6, 7, and 18. Try on your own. Yes, I'm going to be writing X too. So 6 is 15x squared plus 4x minus 4 equals 0. Number 7, 7x squared minus 38x minus 24 equals 0. And 18 is 3x squared plus 36x plus 49 equals 8v. Okay. Oh, x. My bad. All right, I will pause this. You guys can either do these by factoring or using the quadratic formula, and I am happy to help if you need it. We go. All right, so we're going to start by looking at number 6. So for number 6, if we were going to use the illegal method where we multiply A and C, let's just start by, I'm going to rewrite the problem below. So 15x squared, just so I have room, plus 4x minus 4 equals 0. So if I am using that new method I just taught you, or I just showed you, I didn't come up with that. What would my first step be? What should I do first? Perfect. We're going to multiply 15, or whatever the value is for A. We're going to multiply it times negative 4, or whatever the value is for C. So, let's write a guide. Step 1, multiply. A times C. So, 15 times negative 4, what is that? Good, negative 60. So 15 times negative 4 equals negative 60. So we just multiplied A times C. Where do we go from here?
You have to do 4 times negative 4. Wait. Sorry.
You snuck in here. I was like, what? Let me mark that you're here. Okay. Were you in here whenever I showed this like new method?
The x equals negative, B, that one?
Ooh, that one was from yesterday. Were you here today whenever I showed like this new method where we
I've got you.
multiple? Okay, you just got in here. Okay, so we are learning a new method. that you might not know about yet.
Okay, so I'll just be quiet.
You're okay. You're okay. Let me mark that you're here and you'll catch on. You'll catch on real quick. Okay, so whenever our A is greater than 1, factoring to solve can take a really, really long time. So we just learned this new trick where we can ignore that A is bigger than 1. And we're going to start by step 1, multiplying whatever your A is, 15, times whatever your C is, -4. So we did that. We multiplied A times C, and we got 15 times -4 is -60. So what we do with that is that -60 becomes the new C term, and the A disappears. We're going to pretend it's 1. So now we're going to rewrite the problem as x squared plus 4x minus 60 equals 0. So we multiplied A times C, and then we rewrote the equation. With the new A and the new C. So here's our new equation. X squared plus 4x minus 60 equals 0. Now, again, I want to encourage every person in this room that if I write something down and you don't know where it came from, tell me that so that we can talk about it. I don't want anybody to leave this room confused. Okay, so we are to this point. Now that I have my A reduced to 1, it's a lot easier to factor. So, what will my factor pairs look like? X and X. Now we don't have to worry about splitting up 15 into either 15x and X or 3x and 5x, 5x and 3x. It gets really complicated and really long very quickly. So now we have just X and X. And what will we do to figure out what goes in these parentheses? Yes, we're going to look at the factors of -60, our C. And what signs will my factors have? A positive and a negative. Since it's a negative number, we need different signs, so they multiply to a negative. So we have, I'm going to look at my factor pair sheet. 60 has a lot. -1 and 60, -2 and 30. We could, of course, swap these signs later. -3 and 20, -4 and 15, -5 and 12, -6 and 10. Now, if none of these work, of course, we can try flipping the sign onto the, or the negative sign onto the other number, but let's start with these. What do my factors need to add up to again? Yes, it needs to add up to that +4, my B. So let's check these out. -1 and 60, will that add up to 4? No. -2 and 30? No. -3 and 20? No. -4 and 15? No. -5 and 12? No. -6 and 10? Yes! -6 plus +10 equals +4. So these are the numbers we'll use in our factor pairs. So -6 plus 10. Plug those in. Okay. So, step 1 was that we multiplied the a and the c, and then we rewrote the new expression. Step 2 could just be to factor like normal. After factoring like normal, how would we solve for x? Yes. X minus 6 equals 0. And x plus 10 equals 0. Good. Okay. Which will give us values of positive 6 and negative 10. So we have x equals 6 and x equals negative 10. Are we done? No. One last step that is part of this new method. Since we multiplied by a at the beginning, what do we need to do at the end? Divide by a. So, step 3, divide x values by a. So, what was a again? 15. So, now I need to take 6, divide by 15, and negative 10, divide by 15. So, let's see what that gives us. 6 divided by 15. And you could write them as fractions. Absolutely, we could simplify these. Now, the answers on the worksheet are written as fractions. Let me find my worksheet. Where did it go? Not that one. No, maybe I left it somewhere. So, on our answer sheet, this was number 6. It says that we should be getting negative 2/3 and positive 2/5. So, let's see what these simplify to. 6 and 15. Is there anything they're both divisible by? 3. So 6 divided by 3 is 2. 15 divided by 3 is 5. So there's one of our answers. That on the worksheet it says x is 2/5. There it is. X is 2/5. Now we could try simplifying negative 10 over 15. What could I divide them both by? 5. Negative 10 divided by 5 is negative 2. 15 divided by 5, 3. So we get x is negative 2/3, which is our other answer for number 6, negative 2/3. So we could do it that way. Now, whenever we start graphing equations like this, I prefer decimals, but you will not get counted wrong for using fractions. You can use fractions if that's what you prefer. Decimals, I think, are just a little bit faster to figure out on your calculator. So just trying to save you guys a little time in the long run. So we could either have x is 2 over 5, or you could say 0.4, negative 2 over 3, or negative 0.6 repeating. Good deal. So if you got these as your two values of x, all of these are correct. Did anybody get something totally different? Well, good deal. Okay. Awesome. All right, guys. So I know that was only one of those 3 problems, but it is 10:32, and I want to give you guys a little break. So let's look at the other 2 whenever we get back from our break. I'm going to say let's come back at 10:55, a little before 11. That gives us a little over 20 minutes to take a break. So, on break, back at 10:55. All right. Okay, so we are back from our break, and we just solved number 6. So now let's look at number 7 on that worksheet. And once we go through and solve 7 and 18, we're going to transition from the factoring method / this quote-unquote illegal method over to the quadratic formula. So let's look at number 7 now. I'm going to rewrite all this. Algebra 2. Continuing our day 9 notes. And this is my page 5. Okay. Okay, so number 7, we had 7x squared minus 38x minus 24 equals 0. Okay, using that new method, what is my first step? Perfect. We're going to take 7 times negative 24. So 7 times negative 24. What is that? What's the product of those numbers? Negative 168. Okay, so we multiplied our A term times our C term, and we got negative 168. So when I go down to the next step, how will I rewrite this equation? X squared minus 38x. Perfect. Minus that new number, 168, equals 0. Okay. So now we're here. What do I do next?
List factors of 168.
Perfect. We're going to list out the factors of our new C value, negative 168. And if you're using that factor pairs sheet, it looks like this. 168 is not on there. So, what's an easy way to find all the factors of a number? We can start just dividing by small numbers and get to larger. So we'll start with 2. Let's see. Negative 168 divided by 2 gives me 2 and negative 84. Can I divide by, let's try by 3. Ah, it does work. 3 and negative 56. Negative 168. Now let's try dividing by 4. Does work. 4 and negative 42.
Negative 4, positive 42 is the answer.
Oh, okay. -4 and +42. How do you know that's the answer?
Equals -38?
Yes.
When you add it together, it's just -38.
Okay, so we need our numbers to add up to -38. So let's try both of these because they're close. -4 plus 42. What will that give me?
That's 38.
Ah, so that'll give me +38. But my B is -38. So these are the correct numbers.
You just swap the sign.
We want to swap our signs. So that means we'll want -42 and +4 to get -38. So these will be the numbers we'll use. But our x value will end up being -4 and +42. So that's one step ahead. So I've got my two numbers. How do I use 4 and -42? X plus 4 and x minus 42 equals 0. Okay. And our next step, inverse operations. So we have x plus 4 equals 0 and x minus 42 equals 0. We'll solve by doing the opposite. Subtract 4 from both sides. Okay. And that gives us our first answer of x equals -4, and we'll add the 42 to both sides for the next equation, and we get x equals +42. But are we done? No. Now, because at the beginning we multiplied by 7, we divide by 7. So, bring that down. Divide by 7. So we're going to take both of our answers, which are -4 and +42, and we'll divide those by +7. So -4 divided by 7.
-0.57.
Awesome. -0.57. And 42 divided by 7 gives us what? 6. So our answers are x equals -0.57, comma, +6. And that's how we would write them. Okay. I'll give everybody a minute to finish writing if you are still doing that. But as you're copying this down, do we have any questions about what we just did? Any questions at all? Move up a little. Okay, can we move on to number 18? All right, let's do that one last problem together. So number 18, we had 3x squared plus 36x plus 49 equals 8x. Okay, so here is my beginning problem. What is the issue with this problem?
Equal 0.
It is not equal to 0, so how can we fix that? Yeah, we're going to subtract 8x from both sides and get our equation equal to 0. That'll be our first step. So I'm subtracting 8x here. Where else do I subtract 8x? 36x. Good. Okay. And we'll bring everything down. We still have 3x squared plus, what's 36 minus 8? 28, thank you, x plus 49 equals 0. So now we're in standard form. Okay, what should we do from here?
30 times 49.
We could take 3 times 49 to get rid of that 3, then we don't have to worry about 3x and x. So, what is 3 times 49?
147.
147. So 3 times 49 is 147. So how do I rewrite this quadratic equation?
X squared
X squared
plus 28x
plus 28x.
plus 147.
Good, plus 147 equals 0. Perfect. Okay, and I feel like we found the factors of 147 earlier. We did some of them. On this problem, we found the first two, 3 and 49, 7 and 21. So let's start there. Okay, so now we're finding the factors of our new C, 147. So we had 3 and 49, 7 and 21. And what should they be adding up to again? 28. I think we've already got one that's going to work. Seven plus 21 is going to give us 28. So that is going to give us the two numbers we'll use in our factor pairs. So what are the factor pairs now? Perfect. X plus 7 and x plus 21 equals 0. Okay. So from here, where do I go?
Inverse operations.
Inverse operations. We could set both of these equal to 0. X plus 21 equals 0. Okay, and inverse operations will tell us to subtract 7 from both sides, giving us an x value of -7. And same with x plus 21 equals 0. We'll subtract 21 from both sides. And we'll get x equals -21. Now, are we following up to this point, or is anyone unsure about any step I wrote down? Okay. Where do we go from here?
Divide by 3.
Yes, now we have our answers and we just need to divide by 3 since we multiplied by 3 at the beginning. So, divide by 3. -7 divided by 3, what will that give me? 2.3 repeating? Negative, good. 2.3 repeating. And -21 divided by 3? -7. Very, very close. 21 divided by 3 gives us 7. And since it's negative, it'll be a -7. And those are our answers. -2.3 repeating and -7. Okay. Are we okay? We feeling all right? Is this a little bit easier than the rainbow method? I think so too. I think it is. That's good. Okay. Does anyone still need to see this work, or do we have last second questions? Okay. Okie dokie. Well, then we're going to move on and look at the quadratic formula again. So, let me just reorganize my papers. Let's see. Okay, so for the first half of class up until now, all we have done is solve by factoring. That's it. So we're just going to talk about the quadratic formula as well, because I find it depends on the type of person you are, but when I was in high school, the quadratic formula was my preferred method, because sometimes, you know, every question I've given you is factorable. These are all equations that can be factored. But in the future, not every quadratic equation can be solved by factoring. And sometimes it takes a long time of writing out your work to figure out it cannot be factored. However, on the quiz, I know we have such limited time in here, I will tell you if it can't be factored to save us some time, because I would hate for you to spend an entire class period figuring out that one thing can't be factored. So I will give you that information. But in the future, if you go on to college and things, they probably won't tell you. So it's important to look at both options. So let me just keep titling this. Notes continued. Okay. So we're going to sing our song again. I'm going to write it out. And once I have it all written out, we're going to sing a little. So here's the quadratic formula. Very important to know this. Of course, you'll be able to use your notes on any quiz, but having this formula memorized will make your life so much easier. So the song helps. So I am going to write it out. X equals -b plus or minus, let me zoom on that a little, the square root of b squared minus 4 times a times c. So there's the top half. And then a big line over everything, or under everything. All of that will get divided by 2 times a. Okay, so I want you to repeat after me, echo me a little bit, and then we'll do it all together. So we're going to go a little bit piece by piece. We'll start with x equals negative b. You ready? You going to sing? Just try your best. I swear it really helps. Okay? X equals negative b. Good. Plus or minus the square root of b squared minus 4ac. Yeah, Cody, come on. All over 2a. Okay, one more time, but louder. Ready? We're going to do it all together, no echoing. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. One more time. Here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Yay! I know, guys, it feels weird singing, but that actually helps a lot. Maybe you hate it, okay? I understand. Maybe you love it. That's great too. I find it helps if you memorize this formula. If you don't, it's still possible to do these problems because you can use your notes. You'll have it with you. But, I don't know, it was something that helped me when I was growing up, so I teach it. Anywho, here's our formula. I like to color code it because colors help me a lot. And I have found colors helpful with all of my students. So, here's how we're going to do it. I believe in previous notes I made A orange. Is that right? Does anybody remember? I can never remember. I bet you've got it, Lisa. What color did I make it? Orange was A. Okay, perfect. B was purple. Perfect. C was blue. Okay. So I'm going to use colors because the hardest part of this formula is figuring out what number goes where, and sometimes using colors helps me keep those straight. So we're going to make A orange, B purple, and C blue. And we're going to go back to the problem we just solved. Number 18. So I have 3x squared, and I'm going to go ahead and use the version where I'll show you. We started with an equation where it was equal to 8x. I'm going to go ahead and have us use the version where we got minus 8x on both sides, and now we have it back in standard form. So 3x squared plus 28x plus 49 equals 0. Okay. So, what is our A value? 3. What's our B? 28. Good. And our C? 49. So all I have to do is match in my formula the number that is the right color to the number that is missing in the same color. So let's rewrite our formula without ABC and with the number values that go there. Okay. So I'm going to have x equals. Now this is one part that I think really confuses a lot of people for some reason. What are we going to write since it says negative b. Our b is 28. Negative 28. Good. That minus sign stays there. You're just putting the number beside it. And the number is 28. So that's my b. Negative b. Negative 28. Plus or minus comes next. After that, our square root. What do I write next? Yes, it's b squared, so 28 squared. What comes after b squared? Good. Minus 4 times a times c. So I'm going to leave 2 parentheses there. What's my a again? 3. And my c is 49. Okay. Am I done? All over 2a. Don't forget that part. So all of that gets divided by 2 times a, which is 3. Okay. So we have our numbers plugged in. And I know especially if you're following along with colors, this can be a time-consuming process to plug your numbers in. So I'll give everybody a minute to get caught up to where we are and just get all those numbers plugged in. And let's see. All right, where do I go from here? Now that I have my numbers plugged in.
You do minus 4 times 3.
Absolutely, we could do that first. Basically, the next thing we need to do once our numbers are plugged in is we need to simplify anything that we can in the correct order. So we could either do our 28 squared, or since these are kind of separate, we could start with that negative 4 times 3. What is negative 4 times 3? Negative 12. So I'm going to always cross things off as I simplify. So negative 12. And that still needs to be multiplied by 49, right? So I'm going to write that up here. What do I do next?
Multiply by 49.
Sure, let's do negative 12 times 49. What does that give us? It's a big number. Negative 12, I'm going to type it in, make sure I get it right, times 49. Negative 588. Okay, so negative 588. Okay, so I've gotten this half simplified underneath my square root. What else do I need to do under the square root?
28 times 28.
Yeah, we're going to do that 28 squared. So 28 times 28. And that gives us 784. So now we're left with a problem under the square root. 784 minus 588. What is that going to give us? 196? Absolutely. So that means we have the square root of 196. That's what is under our square root now. We did 784 minus 588. Okay. Now, what is left to simplify before we rewrite things? Somebody said it earlier.
2 times 6.
2 times 3. We want to simplify that, and what is 2 times 3? 6. Okay, so I'm going to bring everything down and rewrite this. X equals, what comes after x equals? Negative 28.
Plus and minus.
Good, plus or minus.
Square root of 196.
Perfect, square root of 196 divided by 6. So now we've gone from this mess down to this. Negative 28 plus or minus the square root of 196. All of that divided by 6. Before we move on to the next step, does anyone have questions about how we got from here to here? Or is it making sense so far? Everybody understand it? Okay, okay. No questions yet? Okay, all right, that's...
Can't you get rid of the 196?
Yes.
Plus the 14?
Absolutely. We can do the square root of 196 because let's just see if it gives us a nice clean number. Now, if you forget how to do a square root on your calculator, I'll show you. That x squared button right next to 7, if you notice right above it, there's a blue square root symbol. To access any of the blue characters, you're going to hit the blue second button at the top left-hand corner. So I hit that, and then I'm going to hit x squared. And now I have a square root. I'll just type in 196 and hit enter, and we get 14. So we can go a step further. Now we have x equals negative 28 plus or minus 14 divided by 6. Okay. Are we following here? Do we see where we got from here to there? Okay. Now, what do we do next?
Break it up.
We could break it up into our two problems. Now, there is an option that I usually don't teach just because I notice students make the most mistakes whenever they try to simplify. At this point, you could technically simplify this like it's a fraction. If there's anything that all three numbers can be divided by, we can reduce them. If you like doing that, great. I'm not going to directly teach that method just because I notice a lot of students make mistakes at this step. But I'm going to do Cody's suggestion. Now that I have all just regular numbers, I don't have any more real operations, we're going to look at that plus or minus, and we're going to split this up into two problems because whenever we solve a quadratic equation, we typically get two answers. So here's how we split it up. We will have a plus and we will have a minus. The plus, we'll write negative 28 plus 14 and then divide by 6. the minus. Anybody guess what I write for minus?
Negative 28 minus 14.
Perfect. Negative 28 minus 14. And then divide by 6. Okay. So, let's work with our plus problem first. What do we do first in this fraction that's happening here?
Add the 2 on top.
Yes, we need to add the two numbers on top first. So, negative 28 plus 14, what does that give us? Negative 14. And don't forget, we still divide that by 6. And what will that give us?
Negative 2.3 repeating.
Perfect, negative 2.3 repeating. And next one, we have negative 28, minus 14, negative 42. And that's still divided by 6. Let's see. Negative 42 divided by 6, negative 7. So, our answers would be x equals negative 2.3 repeating, comma, negative 7. And look at that, we got the same answer when we solved by factoring. 2.3 repeating, negative 7. Or sorry, negative 2.3 repeating. So both methods work. Both of them work. Okay, any questions up to this point? Okay. Do we want to work through a few more of these together before I have you try some of this on your own? Or y'all want to try this on your own? I'm going to let you try some on your own, I think. Okay, I'm going to move this. Is that okay? Can I move it? Okay. So, I want you to do, let's see. This will be your exit ticket. Now, if anybody wants a copy of the exit ticket before I write it, if you don't want to have to copy it down, that is absolutely fine. You're welcome to wait, and I will give you a copy of that. But if you are writing your exit ticket yourself, please just write that it is the day 9 exit ticket. Okay. And this is due Friday, just like all the other exit tickets. And I believe Friday is April 11th. Okay. So I'm going to give you 2 problems, and I would like for you to be able to do both methods. So I want you to do one of each. So, solve each quadratic equation below. I want you to solve 1 by factoring. And solve 1 using the quadratic formula. Okay, and I will write the quadratic formula on here. Negative b squared minus 4ac. Okay. So your first problem . X squared minus 9x plus 8 equals 0. Here's your first one. And your second one . Let's do 7x squared minus 31x minus 20 equals 0. Okay, there are your 2 problems. I want you to factor 1 and use the formula for 1. So I'll leave this up here and freeze my screen, and then I am going to make copies of this. How many of you would like copies that are in this room? Okay, 1, 2, 3, 4. Anybody else? Okay, 4 of them. I'll get that going. Okay. That is going to be all today. So I will go ahead and end this video. And as you're working on this, if you got questions, just let me know.